Good morning, Wolfpack, and welcome to lesson 3.3, Dilations. I'm asking you to please make sure that you are on your best behavior for the substitute teacher today. We are going to be doing lesson 3.3, Dilations. That means that for some of you, I have skipped lesson 3.2, and that's okay. We will do 3.2 when I get back to class. I'm also going to divide up this lesson into a couple of videos, so that way it breaks it up a little bit, so make sure that you are staying focused and following along. Let's do our notes first. A dilation is a transformation that stretches or shrinks a figure. You could also use the word enlarges for stretches and reduces for shrinks. It changes the size of a polygon, but it leaves the shape unchanged. So if it was a triangle, it stays a triangle. If it was a rectangle, it stays a rectangle. It may get bigger or smaller, but the shape does not change. Therefore, dilations produce an image that is similar to the pre-image. We'll talk more about similarity another day. A dilation has a center of dilation and a scale factor. That center of dilation and scale factor together determine the position and size of the new image of a figure after the dilation. The center of dilation is the fixed point about which all the other points are transformed by the dilation. So the center is a point, so a set of coordinates, an x, y. Dilations involve multiplication, which would be stretching or enlarging, or division, which would be shrinking or reducing. The scale factor is the number or the value by which a figure is multiplied. So to find the scale factor, you take the length of the side of the image and divide it by the length of the side of the pre-image. And if you're multiplying your number by a number that's less than 1, so less than 1, it's going to cause a reduction. It's going to get smaller. By multiplying something by half, I'm going to get a smaller amount. If you're multiplying by a number that's greater than 1, you're going to have an enlargement. It's going to get bigger. And that should make sense. A couple of properties, and I'm going to go over these, but we won't discuss them a whole lot. They're just out here for you to see. Dilations preserve angle measure. So if angle A was 45 degrees, angle A prime is still 45 degrees. The angles do not get bigger or smaller. The second point is that dilations preserve betweenness. If it was between, it's still between. Okay? So that should make sense. If it was between A and B, it's still going to be between A prime and B prime. Dilations preserve collinearity. If it was on the same line, it's still on the same line. Okay? These three properties are also true for translations, reflections, and rotations also. The fourth one is that dilations preserve orientation, which is the direction. So it's still going to be facing the same way that it was facing beforehand. Dilations map a line segment of the pre-image to another line segment of the image, whose length is the product of the scale factor and the length of the pre-image. And lastly, dilations map a line not passing through the center of dilation to a parallel line and leave a line passing through the center unchanged. Those two properties, they're on here. We really won't discuss them a lot in geometry. We care mostly about the first four. Okay? If you look at the examples, you can see that AC was 3, and now A prime C prime is 6. It dilated by a scale factor of 2. And if I took all the coordinates of A, B, and C and multiplied them by a scale factor of 2, we'd end up with A prime, B prime, C prime. But the second example is a non-example of a dilation. And the reason is AB was 4, and A prime B prime is still 4, so that did not shrink at all. Okay, but you can see that BC was 4, and B prime C prime is only 3. So one side shrank, but the other sides did not. Also, distance was not preserved. You can see it's not facing the same direction as it was previously. The first thing that we're going to do is we're going to find the center of dilation and the scale factor of the dilation. So the center of dilation means that, to find the center of dilation, we're going to draw a line from the image to the pre-image, or from the pre-image to the image. So for example, from A prime to A, I'm going to draw a line. I'm going to try to make it as straight as I possibly can, but I'm on the smartboard. And then from B prime through B, and then from C prime through C. And those are not perfectly straight, so I'm going to try it one more time and see if I can get it a little bit better. But again, hopefully on your paper you're doing okay because you have your pencil and you have it right in front of you. So A prime through A, B prime through B prime through B. There we go. C prime through C. So I drew my a line from my image to my pre-image, and they all intersected right here. That's my center of dilation. So the center of dilation, in this particular case, is 0 on the x-axis, 0 on the y-axis. That's my center of dilation. Now my scale factor, you remember, is image over pre-image. So I'm going to erase this so I can see a little bit better. My image length of A prime to B prime is 1, 2, 3, 4, 5, 6 units long. And my pre-image of A to B was 3 units. 6 divided by 3 is 2, so my scale factor is 2. Let's try example B. So example B, I'm going to draw a line from my K to my P, draw a line from N through J, and I can stop right there because I see that they already intersect right here, but I'm going to keep going just for the sake. I'm going to draw a line from L through Q and M through R. You can see they all intersect at the same point. So the center is 0, 0. Now don't get your hopes up. The center is not always 0, 0. These are just our easier examples, so they happen to be this time. We also need to find our scale factor. Our scale factor is image over pre-image. Now I don't have any primes here, so I'm not sure which one is the pre-image and which one is the image. But I have told you before that if they don't tell you which one is the image and which one is the pre-image, then assume it goes alphabetically. So that would be J, K, L, M, N mapped to J, P, Q, R, S. Okay? So the length of the side of my image divided by the length of the side of my pre-image. So I'm going to do JS. So JS is 1, 2, 3, and JN is 5. Cannot be reduced at all? No, it cannot. So my scale factor was 3/5. Okay. We're going to stop right there, and I'm going to record the rest of this on a second video. Again, please make sure you're following along, that you're filling in everything you're supposed to. If you have any questions as we're going along, go ahead and write them in your margins, and we'll go over this together. These properties that we talked about on the front, are they here? These properties, the bottom two, I'm not really overly concerned that you know, but the top 4 are really important. Okay? The top 4 are really important. They preserve angle measure. The angles don't get bigger or smaller. They preserve betweenness. They preserve collinearity. If they were on the same line, they're still on the same line. And orientation, they're going to face the same direction. Have a great day, and I will see you on the next video.